Hey there, in this video I'm going to talk about Boyle's law. So over here, as you can see, I have piston 1 and piston 2. And piston 1 we have greater volume, and piston 2 we have lesser volume. Let's say the volume of piston 2 it is halved of the volume of piston 1. So you have lesser volume in piston 2. So if we have lesser volume in piston 2, which means we have more molecules per cubic meter, right? Per cm cube or meter cube. It depends how you calculate it, which SI unit that you are using. But they are basically the same. So and again, if you have lesser volume, you will have more molecules. In this case, the temperature it is constant for both of these pistons. So since you have lesser volume and you have greater molecules, which means the amount of force exerted by the molecule over this area right here, it is doubled of the amount of force exerted by the piston 1, the molecules in the piston 1. As you can see right here, we have greater surface area and the forces it is spread out. Okay, it has been spread out, but in this case the force it is concentrated, so which means we have more pressure. So in summary, if we have greater volume in constant temperature, if we have greater volume, so we will have lesser pressure over here, which means we have lesser pressure per cm square or meter square. It depends how you use it, which SI unit that you're using, but they are basically the same thing. So right here we have lesser volume, but we will have greater pressure. So this brings us to the Boyle's law, which is for fixed mass of gas at constant temperature, the pressure it is inversely proportional to the volume, which means if you have greater volume means you have lesser pressure. So it is same in this for this piston 1 and piston 2. So this brings us to a formula. It is going to be P1 times V1 equals to P2 times V2, which means you have greater pressure, you will have lesser volume, and lesser pressure, you will have greater volume. So it is constant because the temperature it is constant in this case, and the number of molecules it is constant. So if the temperature it is constant and the amount of molecules in a particular closed system of volume or container it is constant, so this formula it will work. So this is for constant temperature. So let's try an example, a question. I'm just going to erase this diagram first. Let's say the pressure it is going to be 2 and the volume it is going to be 5 cm cube in this case, and the volume it is 2.5 and the pressure it is unknown. We have to find the pressure, our new pressure, and the temperature it is constant in this case, in this particular case. So let's try it out. So our initial pressure it is going to be 2 and our initial volume it is going to be 5 equals to our new pressure, our new volume. So our new volume it is going to be 2.5 and our pressure it is unknown. So let's just move it around. So 2 times 5 it is going to be 10 over 2.5 and x. So the x it is going to be 4 and pressure it is going to be 4. So let's put this into this formula again. 2 times 5 equals to 5 times 4. As you can see right here, the pressure and the volume, and the pressure and the volume in this case. So as you can see, if we decrease in pressure on our left hand side, and in our right hand side we will increase in pressure as well, so 2 and 4. And for the volume, we have greater volume on our left hand side, which is our initial volume. So after we have like compressed it, So our final volume is going to be 2.5. So as you can see, if you increase in pressure, you will decrease in volume. If you increase in volume, you will decrease in pressure. That's simple for constant temperature. And this is Boyle's law. And that's it for this video. I hope you have understood what I have just explained. Do remember to subscribe to my channel, and I will see you in the next one. Bye.